Thank you so much. It's a bit peculiar to speak English to my neighbors in Denmark, but I know that sometimes we have difficulties in understanding each other, so I hope you will be okay with this. Can you all see the screen now? I just can see Martin. You see the screen now?
We can see the screen, Christina.
Perfect. Yeah, so I was asked to talk about literacy in science education and about why it's not just words, but so much more. Just to say something very short about myself. I work at Stockholm University mainly, but also at Linnaeus University and Linköping University in Sweden. And I'm a linguist. My background is as a linguist, but I have been more and more interested and connected to different research projects in naturfag, in biology, chemistry, and physics in different school grades. But I'm not from science from the beginning, so sometimes you know much, or not sometimes, you know much more than I do about the subject. But I am interested from the linguistic point of view, and I have been more and more, apart from language, I'm into multimodal, the other kind of resources that we use. So that's very short about my background. So then I hope I can start this. Okay, so the idea about talking about disciplinary literacy is that the fact that in different disciplines, there are different knowledge worlds. And that means that we need different languages. And I put languages into citation marks because I talk about language in a very wide sense. And here I have just some photos from different school subjects. And you can see just by looking at them that you do different things in different school subjects. And since you do different things, you need to talk about things differently, and you write texts that look differently, etc., etc. So that's the background. And I have one definition of disciplinary literacy. I will give you a couple of them, but this is from one of the, I would say, a reference that many people connect to when they talk about disciplinary literacy, and that's Timothy and Cynthia Shanahan from 2012, where they define disciplinary literacy as the specialized knowledge and abilities possessed by those who create, communicate, and use knowledge within each of the disciplines. And that makes it that what we can make out of that is to be able to make meaning, and for students to be able to show the knowledge within the field, a subject, a discipline. They need to use disciplinary relevant resources and text structures. And I will give you some examples of this later on. But first, I will give you a background. I think that Martin and Jesper, they said that a good idea could be to start with, I'll show you this. I don't know if you can see it. It's always hard with this Zoom. Anyway, this is from a book that I edited together with Koxing Tang. It's called Global Developments in Literacy Research for Science Education. And we wrote an introduction to that book. And much of what I'm going to say now to start with is connected to what we write in that book. I have all the references in my PowerPoint that you can get access to later. So as a background, and maybe this is the way many teachers in different subjects think of working with literacy in their different subjects. So this is where people might have started a couple of decades ago. They talked about content area literacy and literacy across the curriculum. And they said that every teacher is a language teacher. So reading and writing belong to all different school subjects. And the focus was on some kind of generalizable reading and writing skills. And they suggested reading and writing strategies to be used in science classroom. That could be reciprocal teaching, concept-oriented reading instruction, etc. And this is not what I'm going to talk about, but this is a background. So this is, in a way, no, it's not really connected, but it's more than words. But this is, I think that some teachers might feel, this is not my area. I'm not going to teach reading and writing in my subject. And I completely agree, because it's not about teaching reading and writing. It's about using language and all the different resources within the discipline, within the subject, the way you use the words, etc., in the subjects. So the next step, or in the history of literacy, disciplinary literacy, the next step was that an insight that different fields, as I started with, have different linguistic and discursive features. And research interests among researchers then was to look at language use in science classroom, and here Lemke, Mortimer and Scott, and other references that you might be familiar with, they came out of this. And also we have from systemic functional linguistics, where I'm from that background more or less. I use that a lot. Halliday's ideas about how we use language and how content and language is intertwined. So researchers analyzed science texts and other texts from other subject areas, of course, and also looked at recurring patterns of scientific genres. And from this perspective, another definition of disciplinary literacy is from Ho, Rappa, and Tang from the same book, that disciplinary literacy refers to specific ways of talking, reading, writing, and thinking, valued and used by people in a discipline in order to successfully access and construct knowledge in that discipline. So that's quite closely connected to how language is used. And then we have a kind of multimodal turn, more and more interest in the fact that all interaction, all communication is multimodal. We don't use words only. There's so much more. So when we talk to each other, we use gestures, etc. And then we looked at the multimodal aspects of the discourse of science, both in texts but also in classroom practice, etc. So here we are interested in the use of images, graphs, diagrams, concrete models like ball and stick models in chemistry as an integral part of the science discourse. And I want to stress that is together with the verbal and written spoken language. Sometimes when you talk about multimodality, it's like we forget about the verbal parts, but it's the combination that is interesting. And I have picked, it's a Swedish example. It's from a Swedish book in chemistry from one of the projects I've been part of, where I just to show you some examples of what could it be, the disciplinary language from a multimodal point of view, also in just a science book. So we have different words. I think you understand Swedish well enough for this. So subject-specific terminology, and I haven't marked all the terms, etc., but just some examples. So we have subject-specific terminology, but also subject-specific symbols like the chemistry language. And also we have different kinds of models. And here I was interested in the multimodal aspects of science, partly because I met this book, and since I'm not all that familiar with chemistry and the atomic model, I was quite amazed that the students, they met different models for sort of the same thing. So here we have 3 different models, all showing sort of the same thing, ionic bonds between natrium and chloride. I don't know the English words. So models as well, like this. And also, we have some symbols with multiple meanings. Like, I don't know if you read about this before, you probably noticed that arrows can mean so many different things. It could mean this is in this, I don't know if you can see where I point. Can you see that? Yeah. So here it's the arrows pointing different ways is to say that these are attracted to each other. So that's quite confusing because they point the other way. And here the arrow is a movement, an electron jumps to, and it could be a process. It could be so many different things. So this is also part of the disciplinary language. And also what I noted was that there were so many metaphors and analogies used to talk about the atomic model. Here it's about attraction, and the students probably don't know about attraction in this sense. And it's the same way that the comb and a hair are attracted to each other. And also nominalizations, which is quite typical for the science text, to make verbs and adjectives into nouns, giving and taking, etc. And also connective words that are very, very important for getting the content right. So these are all different sorts of disciplinary language in a text. And a small detour, talk about models and models in science. This was something that I noted after a while in the field, that models in science, I mean, they describe scientific phenomena that are not visible to the naked eye, and to describe our current understanding of phenomena. So this is typical for science. And what you could comment on is that this model does not comply with what we know today, because experiments have shown that this is inadequate. So there's some kind of, we try to show what we know about the atomic model, and that changes because we learn more. Which is different from, for instance, models in social science, because here we have models to describe and reason about abstract social phenomena. It's not that we don't know other things about, in this case, the Swedish social security system, which is here used in a metaphoric way as water pipes connected in different ways. So what we can comment on here is, so what becomes highlighted through this model, and does it contain an explicit or implicit values? Should something else or something more be added? So there are quite different ways of using visual models or models to make meaning in these different subjects. And of course, I back here to this again. Of course, every model here highlights certain aspects of a phenomenon and downplays other aspects. So you can use the Bohr's model is quite common to use in schools, because it points to certain aspects that you want to talk about that might be more difficult to talk about when you have this more recent about the cloud of electrons. So that was about models. And also from the multimodal perspective of the discourse of science, we talk about multimodal orchestration, and we talk about multimodal ensembles, that different modes, different resources, they combine to something more than each resource for themselves. And I give you some examples from, this is from a physics classroom, grade 7, where we have, you can look at this, what is written on the whiteboard. It's a multimodal ensemble, it's drawing, a drawn model, and it's words, and it can be different subject-specific symbols, etc. And when the teacher presented this the wave model to describe sounds, he did this as a multimodal orchestration. So he made his drawings at the same time as he talked about it, and he made gestures. And when he had drawn the model or parts of it, he stood in front of it and he made some kind of visualization with gestures about how waves move, the sound waves. And at the same time as he used gestures, you can see that he moved sideways as well to sort of become a wave, a molecule in that kind of wave. So this is what we call multimodal orchestration. And that's quite interesting and important, I think, important for teachers to be aware of the kind of resources that you combine when talking about this abstract phenomena and scientific concepts. And from a research perspective, it's very interesting to see what happens in the classroom when teachers do this and how students pick up these kinds of resources. And finally, I would say, I think the next step is, I'm very much into the multimodal aspects of the discourse of science, but also the disciplinary practices of science. So from that perspective, researchers are and teachers, of course, are interested in the ways to make students engage in the ways that science acts out. So working with predictions, observations, and explanations, etc., and use text as a part of scientific inquiry process, work with scientific explanations and evidence-based arguments, evaluating and communication multimodal information. So these are the 4 perspectives that we point out in our introductory chapter in the book I just tried to show you. So this is yet another way of defining disciplinary literacy by John Airy, one of my colleagues at Stockholm University for the moment. He used to work at Uppsala. So the ability to appropriately participate in the communicative practices of a discipline. So that entails both using the language in a multimodal sense and to do the things that science you should do in a science classroom or in the science discipline. So this is the kind of summary I present in a publication. It's under publication in Swedish, but to look at literacy and discipline in language from some kind of continuum from writing and spoken language to action. And I think from the very beginning was mainly the writing aspect that have been in focus, but then writing and spoken language. And then we have the extended text concept that goes more into multimodality, writing, spoken language, image gestures, etc. But then also embodied and how we make meaning with artifacts and action. So different people can talk about science language or the disciplinary language of science from all of these perspectives. And I think it makes sense to make clear where am I in this? And I think myself, I am more or less in the whole blue banana here, but perhaps since I'm a linguist, a bit towards this extended text concept, etc. So from there, I just have to check the time now. Pardon?
You are in good time, Christina.
That's good. So now we present examples from some projects, and then I might be out of time soon. So I've been in a number of projects, and I won't give you the details about all of them, but I give you some glimpses of what we have done, where we have worked with both work with teachers or just studied what teachers do. But the practices of science, including working with observation of scientific phenomena, premise of predict, observe, explain, etc., multimodal text creation, premise, reasoning, outcome. You might be familiar with these, and using, creating, and refining models in different ways. So my first example is from grade 3 with students the age of 10. And they worked with a particle model in chemistry, which was too early, so to say, if we look at the curriculum documents, but this was a very successful project, I would say. So we didn't decide that we should work with predict, observe, explain, but I have this anyway, because they worked with, we started with an experiment where they took out glass bottles from a freezer and then put on a balloon on this bottle. And before starting, we said, what do you think will happen? So then they talked about that, but then they looked at what happened really. And that was really engaging, as you can see in these blurred faces. So they noted, okay, the balloon, it gets bigger. So how can we explain what happens here? So this was a project where we worked with the way that science people work. So with experiments, and also that they continuously during 6 lessons came up with their explanations. Why do you think this happened? So the first lesson, many of them, they used the idea that, okay, the warm air rises. That's probably why the balloon rises. But then we let them make new experiments with the bottles lying down or upside down. So they noticed it couldn't be that explanation. And again, they guessed, so what do you think would happen if we turn the bottle upside down? Maybe the bottom will blow because it will rise. So they had different ideas. And all the way through these lessons, they made different texts. So this is text from George and Greta, some experiments later, where they made drawings with paper, pens, and clay, or whatever they wanted, and they also connected this, combined this with writing to explain what have you done and what happened. So this is on the way, and finally they made digital animation, clay animations, to show their ideas with a speech over as well. I won't show you that, but they worked for 5 lessons or so before doing this, and they made sort of great explanations. And here they used the, apart from building on experiments, they use modeling themselves, and they use the kind of diagrams that are typical for science in their way. So they combined in different ways, different resources, and all what they used, they got these tools for text creation that have different affordances. What can you do with a pen and a paper? What can you do with clay? And later they had this possibility to make it dynamic with the digital animation. So all these resources have different affordances, but also what they used to show their ideas was with different affordances. So images for spatial relationships, like size, placement, relationship between the wholes and part. And in this case, they combined the macro, the bottle, and the balloon, and the submicro, the particles moving in the bottle and the balloon. And then through writing, as you saw, it wasn't really cause and consequence, but they were on the way to use writing for cause and consequence and for temporal aspects, because it's difficult to show causes and consequences with image. It's good to combine that with verbal language as well. And here's from another classroom. There was grade 5, where we just followed the ordinary teaching and looked at how a worksheet functioned as a resource for the pupils' meaning making of science content, and also for positioning themselves as knowledgeable, which is part of the disciplinary language, to show that you are part of the discipline, so to say. And here they worked with worksheets where they were supposed to, after having played around with torches and made shadows, to explain why does it become a shadow, or why does it not become a shadow, and also explain how shadows are formed by drawing an image. And I was a bit I mean, how can you explain with an image? But we think that some of the students really managed to do that. But most of them, they combine image and writing in some way to make these explanations. And what we did in this article, Fredrik Jeppsson, my colleague, he was the first author, was that we looked at these worksheets and looked at the premise, reasoning, and outcome about light and shadow formation. I will have the premise, reasoning, and outcome in next slide. So what aspects did they express and through writing and image? And when we looked at the writing, wasn't so much, and when looked at the image, maybe not all, but sometimes in combination. And we used systemical functional linguistics to do that.
Christina, you have 5 minutes left.
Yeah, perfect. So what we looked at was the premise, reasoning, outcome, that light travels in a straight line, the continuum, it shines onto object, opaque objects block the light from moving in continuum, shadow is absence of light. When an object blocks the light from moving in a continuum, a shadow will be formed. And then we looked at each and every of these worksheet among the students to see whether they check on the different parts of the premise, reasoning, and outcome. I won't go into details, but here you have some examples of how these students made drawings that were, many of them used like everyday, the sun and a tree, and then you can't really see how the shadows are formed, but they might have written something, the shadow is created behind the tree or something. And a next step on the way towards more disciplinary relevant way of drawing is to have some, you have the light source and you have light rays here, but still it's quite connected to everyday experiences. And then this was the most, I think, advanced image where we resemble the diagrams, real diagrams in the science discipline, with a light source and light rays, something blocking, etc. And this is not the real word, it's something else. So that was interesting in itself. And we also concluded that to make sure that or to assess these, you needed to look at the whole worksheet. What did they express through the different questions and answers, etc. I think I will skip this one because it's not it's under review for the moment. But I will I think finish with going back to the grade 7 classroom with this teacher that we consider was a very good teacher who supported the students in a highly linguistically heterogeneous class. So how he used different modes to support the students, and he let them, I mean, he wasn't afraid to use models and abstract words, etc., but he supported them in different ways. And I don't have a text here. I looked for it, but he sometimes when the students were supposed to read texts, he made comments. So what does this mean? And for instance, what does this show here? Why does it look like this, etc., to help the students read the text, so it didn't just leave them there. And he made this, we had the previous multimodal orchestration, and he came back to that again the next lesson, and he used his voice when he talked about loud sounds or soft sounds, so in many different ways and gestures, etc. He helped the students to make meaning. And they worked with different kind of uppgifter. now I turn into Swedish.
Exercises.
They did exercises. Yeah. To read, to discuss, etc., from different worksheets. And they worked in small groups, and he walked around in the groups while they were working. They were able to translanguage, to use all the kind of resources and linguistic resources and others that they had. And here he used gestures to talk about amplitude and frequency, etc. So that was quite a nice classroom to finish off with, where we also noted that when the student, they had mistakenly described dark and light, bright sounds in the wrong way, but he didn't say anything about it. He just let them work with other things, and then the same students, they had adequate explanations for what is a dark sound or a light, bright sound, which was quite nice, because when you see a teacher not commenting on when students sort of misunderstood things, you get a bit nervous. But here we saw it, he knew about that, and then he let them make meaning together. So this is a kind of wrapping up, I think. So things to bring with you as a, I don't know what you all are, but as teacher educators or teachers or whatever. So meaning making in this classroom, what we looked at was what resources are used, how, by whom, and for what, in connection to the disciplinary language, and how are students encouraged to show their knowledge, and how were they supported to develop more and more disciplinary specific language or resources, and what counted as signs of learning, that the teacher was very aware of how they used gestures and how they used their wordings, etc. So different ways of showing their learning, and also what challenges and possibilities that lie in the different semiotic resources and the ways that they were used in the communicative situation. And here a quite useful concept is affordance. What is the potential for using these different kinds of resources, both the semiotic for showing the content, and also pedagogical affordance. What can you use in class to support students in the best way, which is connected to, do I have 2 minutes left?
Yeah, you can talk 2 minutes.
Yeah, I'll just take you here, I think, or if I just make everything, yes, but because what one of the things that is connected to disciplinary language and disciplinary literacy, and also something that I think teachers and teacher educators could think about, is that that form and content, there are two sides of a coin, that every utterance or every text, depending on for whom and for what purpose and the content, you choose a specific form. So it's all connected, a triad. So me and my colleague Eva Berg-Nestlov, we often we try to push this into teacher education, and to every subject to think about that. And also when students are supposed to create the text, so what is this text going to be about, and for whom is it, and what aspects of the content should I pick out for that reason, and also what's the best form for it. I think this is where I will stop with a tack. Thank you. Tack.
Thank you, Christina, for a very, I like this historical introduction, and also your examples. It shows very, very well that working with literacy is a multimodal approach. Is very operational. You asked what are the people participating. It's a mixture of teacher educators and researchers in science education and PhD students, but also teachers. So it's the whole gang, actually.
The whole gang, yeah.
Yeah,
I hope that you got something out of it.
Yeah.
It's always difficult to find the right.
We now have time for 3 or 4 questions, but in 5 minutes. But I would like, when my colleagues are thinking about what questions they could ask you, I would like to ask one question. Could you describe what you mean by a semiotic resource? Because, well, I'm a science educator. I'm not a linguist.
Thank you for that question. I should have told you before. So a semiotic resource is something that we use to communicate something, to make meaning for ourselves. So a semiotic resource could be a model that I want to use for explaining force, for instance. A visual model, or it could be that I write a couple of sentences, etc. So it's some kind of resource in from the multimodal perspective in any mode, like image, speech, writing, whatever, used for communication.
Okay, thank you. I also have another question, but before I ask this question, I would like to ask whether some of the listeners, are there any questions? Please raise your hand for Christina.
Or comments.
Or comments, of course, yeah. So if that's not the case, Christina, I would like to ask another question, and this is in relation to teachers. What do you think is the biggest challenge about getting teachers to consider literacy continuously in their planning of teaching?
I think a big. I started with this. The first, if you think of literacy in the first sense, then it would be problematic. I mean, the literacy across the curriculum. This is not what we want teachers to do. It's not working with reading and writing as skills. But I think once teachers find that what you do is actually, since form and content are so two sides of the same coin, when you work with the content, you can talk about, okay, so what does this arrow mean? So why? I mean, to get into the different resources, both wordings and how can we best express this? And so I think that's the way to do it. And of course, a challenge is, especially I think in connection to the linguistic part. So if you don't know the grammar, then it's hard to talk about grammar. But I don't think that you need to talk about grammar as such. But if you have the ideas about the specific kinds of words, not just terminology, because that's the first thing that both teachers and teacher educators come up with, the different difficult words. But it's not always the case that the difficult words are the most difficult parts, because they are so obviously difficult, but it could be the other words that are used in different ways, or the constructions that are used in different ways, or to understand that it's very important to be particular when you read. I think maths is the most typical subject when it's so important to read each and every word. Science is sort of, so I think the biggest challenge is to raise an awareness that it's possible. And I'm not the one who think that you should talk about grammar in science classrooms. You should talk about how do we express this as in the best way. and does this make sense, etc.
Okay. Thank you for your answer. I'm looking for hands. There is none. So we will continue now to breakout rooms. I think